Hello everyone, hope you all are doing well. So sorry for the delay in making videos. Actually, if you are new to this channel or this playlist, then I'll let you know that uh, we started solving this data structure and algorithm crash course together. And as I told you that there are, I would say, 60 70 problems related to this, and we decided that what we'll do, we'll pick up each topic. Obviously, like linked list is a topic where you know that okay, this problem is related to linked list. So we'll pick up a topic, and then what we'll do, we'll basically see how we approach a linked list problem related to linked list. What are the different type of possibilities that we can have, and how we can solve a problem, right? So this was the main motive, right? Not mugging up these solutions, not just picking up some of the important problems, rather focusing on the concept and then seeing what are the different kind of problems and how we can approach it, right? But as I told you initially, that we'll be starting with this list, and I'll be adding some more questions, right? Because obviously the number of questions that are visible on your screen are not sufficient to cover the whole linked list part, right? I'm just taking example of linked list here, right? And also just to reiterate, here we have topics like greedy, binary search. So I'll not be telling that okay, now we are going to solve a topic related to binary search or greedy. For those topics, we'll pick up a problem, and then we'll see how we can find whether it's a problem related to greedy approach or DP or binary search and whatnot. But for linked list, you already know that in the problem you are given a linked list, right? So that is why I've just picked up uh, an easy data structure to start with. So what I was doing these days was, let's forget about this crash course, right? What I've done, I was just creating this list that you can see on your screen, and here you can see we have 22 problems. So these problems are basically based on the different type of problems that can be probably formed. Obviously, any list is not exhaustive to cover all the concepts, but yeah, these cover most of the concepts. These also include most of the common interview problems that can be asked, and apart from that, I've also shortlisted some of the problems, though they are not interview specific, but again, good to solve problems, right? So based on that, I've just selected it. So we solved a number of problems from this list, and now what we'll doing, we'll be solving this in a different playlist, right? A playlist is specifically for linked list. So I thought I'll just start from the beginning, and similar to what we have done in the previous videos, we'll start with a problem, we'll see how to approach it, and then how to write the code for it. Also, for the previous problems that we have solved related to linked list, I'll just uh, probably change the thumbnail of those videos and add it to this playlist, so that whenever you come to this playlist, you are able to get all the concepts available for linked list. You don't have to roam around multiple playlists, right? That will be the main motive. So yeah, that's about the intro. I know it's a little bit long intro, but just wanted to know what we are planning to do, right? So the first problem is add two numbers, right? So let's go to the problem statement. So here you can see the problem statement says that you are given two non-empty linked list representing two non-negative integers, right? The digits are stored in reverse order, and each of their nodes contain a single digit. Now add the two numbers and return the sum as a list, right? This is what it says. And what it is given, you may assume that two numbers do not contain any leading zeros except the number 0 itself, right? So there are certain examples as well. So let me just go to the explanation part, and then we'll see what the problem is saying, right? So yeah, that is done. So it says that you are given a linked list, which basically represents a number. Like for example, if we have a number 123, right? So the linked list is in this format: 3 2 1. You read the number from this direction. So what they have done, if this is the number, they have stored it in the linked list in the form of a linked list in reverse order, right? So that is 3 2 1. And what they say is you are given two linked lists in the same format, and you need to add those two numbers and return a final linked list, right? Like for example, if I have a number 342 and I have a number 465, this is the example given. So this will be represented as 2 points to 4 points to 3, and the second number is 5 points to 6, this points to 4, right? So these are the two lists given. Now what we want is, so again, if you add 342 and you add 465, what you'll get, you'll get 7 0, right? And then you'll get 8. So again, what will the reverse of this, it will be 7 0 and 8, right? This is what you will get. So if I start from the left hand side, so just see how you add two numbers, what you do. So if I take the example 342 and 465, you start from the LSB, least significant bit, right? You start from this. So that is why what they have done, to make the problem easy, they have already stored the number in reverse order. So that is why instead of storing 342 as 3, 4 and 2, they have stored it as 2, 4 and 3, so that it is easy for you to do the calculation, because you will be starting the calculation from the rightmost digit, right? So what do? You add these two, so you get a 7. Now in this case your carry is 0, right? What basically you do is, you initially in your mind, what you do, you have a variable. Suppose you calculate the, initially you have a carry, let that is 0, and you have a sum, that is also 0. So you calculate the sum is 2 plus 5, that is 7, right? And what is carry? Carry is 0. So if you add sum plus carry, you get a particular number, and then what you do, you take mod by 10. You take mod by 10, right? So here 7 mod 10 will be obviously 7, so remainder will be 0. So nothing will be carried over to this position, right? Now what you will do, your carry is still 0, your sum is also 0. You come to this bit position, 4 and 6, your sum becomes 10 and your carry equals to 0. You add these two, 10, you get the sum as 10, and then you take the mod. 10 mod 10 is 0, so you place 0 here. And what will be the carry? The sum was 10 divided by 10, carry is 1, so this 1 goes here. So your value, the new value of carry becomes 1 when you go to this bit position. And then what you do, you add, your sum will be 3 plus 4. So sum equals to 7, carry equals to 1. If you add it, you get 8. Now again, what you do, you do 8 mod 10, right? So you place 8 here. And is there any carry? So you do 8 divided by 10, so 0 is the carry, so nothing is left. So 807 is your sum. So this is the basic elementary mathematics that you do, right? Similarly, you will be doing it for the linked list. What you will do is basically, as I told you, the two linked list. So you have 2, you have 4, and then you have 3. Similarly, you have 5, you have 6, and you have 4. You start from this side. Your carry equals to 0, your sum equals to 0. You calculate the sum. So your sum becomes 7. So you do S mod 7. You place this number here. So you create a new node and you place this number here. So it is 7. And what is your new carry? Carry is sum divided by 10. That is 0. 7 divided by 10 is 0. So 0 goes here. Here you have a node here you have a node 7. You go to the next position. So here your carry is 0 and sum is 0. You calculate the sum. It is 10. It becomes 10. You add these two, and as I told you, here you get 0 because 10 mod 10 is 0. So you place 0 here. You again have a node now here, 0, and then 1 goes there. The carry is 1. So for this position, C is this. Sum comes out to be 7. You have 8. You do 8 mod 10. So you place a node 8 here. And what is the carry? It is 0. So yes, this is your final list. And since the carry was 0, you make it null. Now had the carry been non-zero, you see that okay, no number is left here. What you would have done? You would have added a new node and you would have added the carry. Now let's take another case having different number of digits, and then we'll go to the solution so that the explanation is clear, right? So suppose I have a number, suppose I want to add 123 and 4, something like this, or let's add 9 here. So your number will be 3, 2 and 1, and this will be 9, right? Now this is null actually. This is also null, right? What do you do? Carry equals to 0, S equals to 0. So what is your sum? 9 plus 3, 12, right? What you will place here? 12 mod 10. So you will place here 2. Your carry will become 12 divided by 10, that is 1. This is your carry. It goes here. Now you come here, you see that actually this is null, or there is no, the second list has already ended here. So what you will do? You'll do some simple stuff here, that is consider it as 0. So you see your sum will be 2, this value 2 plus 0. And what was the carry? It is 1. So that comes out to be 3, S equals to 3. What you will place here? You will place 3 mod 10. So 3 comes here. What is the carry? 3 divided by 10, that is 0. So you come here. and then finally you do this thing, right? So it comes out to be obviously 132. So here you can see 132. Now there can be some optimizations that we can do. Again, these are some boundary cases. So suppose you have a very long list like 1 2 3. Suppose you have a linked list having a length of 10,000. Number of nodes is 10,000, and suppose you have a number here, let's assume 9, right? Suppose you have a number 9. So as I told you, what we were doing, we were considering these values to be 0, right? But there is an optimization that we can do. What optimization? Now just see here, 9 plus 1 comes out to be 10. So here it will be 0, and 1 will come as a carry, right? So just see, and this number will become 3. 2 plus 1 is 3. Now just see, in this position, after you complete the calculation of this position, your carry equals to 0. So you know that you are not going to change these numbers, these remaining nodes, right? So instead of traversing these nodes, what I can do, if this is my answer linked list, if my name of the linked list, this is answer, what I do answer dot next equals to, so my answer list, this is here, this is here, so this will point directly here, right? So I do not have to traverse these nodes, because obviously my answer will not change, right? So that is why we can do an optimization here. If the length of the two lists that are given varies a lot, then you can do this thing and we'll be good to go, right? So the first one had suppose 10,000 nodes, 10k. Second one has just one node or 10 nodes. So after, at max, you will be traversing 11 nodes here, right? Because the carry cannot go beyond a certain number that you do a carry on the next node as well. Because of this, right? The only possibility is every number is 9 9 9 in the first node, so you get a carry here. So you get 0 here, then again a carry. This is the only case. So as soon as your carry becomes 0, you do not have to carry anything. You just do this thing, that answer dot next points to the next node, this whole list, and then we are good to go, right? Let's jump into the code. Yeah, so this is the code, as I told you. Let me just do this. So as you can see, we are on line number 13. I am making an answer list. Temp is pointing to answer. Initially carry is 0, right? Right. Why I have made a variable temp as well is because I'll be using my answer variable name to traverse the list, to traverse my answer list. That is why. And then finally I'll be returning temp.list. That's the reason. Now line number 16, you can see, while either the list 1 is non-null, or list 2 is non-null, or the carry is not equal to 0. What do? You calculate the sum. So sum is, if first linked list is not null, you take its value or take 0. Similarly, if second list is not null, you take its value or take 0. And then you add carry plus equals to sum. Then construct a new node for the answer. So the name of the node is val, and what you do carry mod 10. Now what is the now answer dot next will point to val, answer equals to answer dot next, and then what will be the carry? Carry will be carry equals to carry divided by 10. Now move both the list one position forward. So if whichever is non-null, you move that forward, and then we are good to go. So we'll be keep on doing this until either all of them unless every list has become, both the list have become null and carry has become 0, right? We'll be doing this, and finally we'll be returning temp dot next. Yeah, right? So yeah, this was a very easy problem, I know, but I just explained you using some using the technique by which we do basic mathematics, basic addition, so that we know what are the basic test cases, and also an optimization, that what we can do in case of the list length varies a lot, right? And carry becomes 0. So you do not traverse the longer list, and you just point your answers next variable, next pointer to the next node in the longer list, right? So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do let me know. I'll be more than happy to revert on each one of them. Thank you. Take care. Bye bye.